Hello everyone, my name is Nathan Zimmerman and I got a little bored over break, so I thought I'd try making a video tutorial on how to find and apply Ohm's law in this particular loncappa problem. So the problem gives us some resistance values, some voltage, and some current values, and it asks us to find R3. Now, to do this, the only basic concept we really need to know is Ohm's law, which is voltage is equal to current times resistance. And let's just start working off what we're given. So at our source here, A, we have a voltage that is equal to 1.1 volts, and we have a current that is equal to 0.36 amps. And we have this resistor right here. And in order to start making calculations over here, we want to find the current across these resistors and we want to find the voltage across these resistors. So in order to do that, we want to find the voltage and the current at this point. We'll call it C. So here's point C, and we have some resistor right here. And the problem tells us that that resistance value is 2.418 ohms. Now, if we can find the voltage across this resistor, that'll help us be able to find the voltage right here. So let's find the voltage across that resistor. Again, according to Ohm's law, voltage is equal to current times resistance. So our V sub R1 is equal to our current times our resistance. So 0.36 amps times R2, which is, or R1, excuse me, which is 2.418 ohms. Now give me a moment as I do that on my calculator. Alright, the value is 8.7 volts. So that's voltage dissipated, or you can think of that as the voltage used up. So initially we started with 1.18 volts. So our V total is 1.1, and then we use up the voltage across R1, and that is equal to the voltage at C. So that is equal to 1.1 volts minus our voltage that we used up, and that is equal to, give me a moment, I need to calculate it, roughly 2.3 volts. And so that is our voltage at C. So again, that's equal to V sub C. Now, we know the voltage at that point. What is I sub C? Well, if you remember in class, as our teacher would say, current is not used up in a series branch. And so the current at A is equal to the current at C, because no current is used up essentially when we're going across this resistor, and there are no other branches for the current to go, so it's just one value. So it's equal to I sub A, which is equal to 0.36 amps. And now remember that this only holds true when all your components are in series. So there's our current at C. So now we have a current and a voltage at C. Now we need to find R3. And at this point, the only thing we really know is the voltage across R3. Because if you look at these two connections, or resistors, they are in parallel. So the only thing we can conclude for sure is that the voltage across them is the same. So V sub R2 is equal to V sub R3. And that has to be equal to whatever this voltage is here, 0.23 volts. And that's simply defined by principle since they are in parallel. However, the current branches out. We have some current in this direction, we have some current in this direction, and our original current is right there. So we know, just using some basic logic and Kirchhoff's law, we know that our current into a node, in this case our node is C right there, our current in is equal to our current out. Now we have 0.36 amps going in, and we know the value of R2, so let's calculate I sub 2. So I sub 2 using Ohm's law, current is equal to voltage divided by resistance. And we know that our voltage going across it, since it's a parallel connection, is 0.23 volts. And we know our resistance is 1.86 ohms. And so with that, we can calculate the current. Give me a moment and I'll have the current. Alrighty, the current is 0.1237 amps. And so that's the current rate here. Our current rate here is 0.1237 amps. And our current rate here is 0.36 amps. So going back to this equation, we can write 0.36 amps is equal to 0.1237 amps plus this unknown value I3. Now, using basic algebra, we can solve I3. I3 is equal to 0.36 minus that value, so give me a chance to calculate that. Alrighty, that value is 0.236 amps. Alrighty, so now we know and that's the current through R3. So now we know the current through R3 and we know the voltage across it. So using Ohm's law, all we have to do is solve for R and we can find the resistance of R3. So R3 is equal to voltage divided by current, and we know our voltage across it is 0.23 volts. And we know our current is 0.236 amps. As you can see, they're virtually identical, so it's going to be a little bit less than 1. Give me a moment to calculate it. It's going to be, for me at least, 0.97 ohms. And so that's how we found our R3. And here's our current through R3, so I'm pretty sure that's all that the problem asks for. Hopefully this recording and technology worked, and hopefully you enjoyed it. I guess I'll see you in class. Thanks.